for the past month, we've been looking into a variety of topics, such as the atmosphere, space weather, and its effects on the satellites and the changes it causes in the atmosphere. We've also been studying high-altitude balloons, and because of this research, we have looked into the following experiments.
By now, all you know what aerosols are, but you might not know how important they are for using in the troposphere. The aerosols block harmful gamma rays, for the most part, from reaching the Earth's surface. In crowded population areas, the aerosols are thicker and provide extra gamma ray protection. China is the leading annual emission for aerosols in the world. We are in second, and India is in third. These aerosols are known as greenhouse gases.
When gamma rays enter the atmosphere, they are blocked by the aerosols, but only to a certain extent. Meteorites and asteroids are blocked about the same. They are usually burned up or blocked, but sometimes they make it through. Take the events in Russia, and their effect, gamma rays have made it through to the surface before, and when they enter the atmosphere more often than we think.
It's possible if we send up our weather balloon with a roll of highly sensitive film, like ISO 6400, and compare it to the film that is exposed down in the troposphere, then we could find evidence of gamma rays in the higher layer of the atmosphere. Gamma rays are typically scattered and follow magnetic current known as the magnetosphere, and create the aurora borealis and the aurora australis. These are called the northern and southern lights.
Is there a difference between the amount of gamma ray exposure at balloons' launch altitude and weather balloons' absolute max altitude? The theory is, if aerosols above the troposphere are blocking them, and if we go into the aerosols or above them, we'll find gamma rays. Now that you have heard our hypothesis, you might be wondering, are there any other experiments we can conduct it?
Well, pressure from the Earth is what we deal with on an everyday basis. It comes at us from all directions. The experiment that we are waiting or wanting to do is high-altitude balloon, and sending it into space to see the layers in the atmosphere. The experiment that I am wanting to do is measuring the pressure, how the balloon goes up in the atmosphere. The layers of the atmosphere, the first one is called the troposphere. The amount of pressure of that is one layer is 1 bar, which means 1 millibar. We are talking about millibars. The second layer is in the atmosphere is called stratosphere, and that is 100 MB, which is millibars.
The third layer is called the mesosphere, which the pressure is 1 millibar. The fourth layer is called the thermosphere, which is the highest layer in the atmosphere, and it is 1,000th of a millibar. When the balloon gets higher in the atmosphere, pressure decreases, and when you're at sea level, pressure is higher. What my class and I want to do is put a Twinkie in the box, or something that will expand so we can see the after effects. We want to put 2 cameras on the box so we can see inside and outside of the box.
Temperature changes are a part of a human's everyday life, but how does temperature in the Earth's atmosphere change as altitude increases? We have come up with this hypothesis, which is if altitude increases, then the temperature will decrease except for when we enter in the stratosphere.
Each layer has a different temperature, and those temperatures decrease in each layer before you reach space. As we rise in altitude, the temperature will drop except for in the stratosphere. This layer has 2 different temperatures. The bottom half is at -3 degrees Celsius. The top half is at 15 degrees Celsius. The reason for the 2 different temperatures is because the top receives more sunlight than the bottom.
With our experiment, we will need these supplies in order to do our experiment. We need a balloon, some helium to fill up the balloon, a temperature radar, 2 thermometers, and an electronic data receiver. With all of our equipment, we will put the whole balloon, and we will gather a ground temperature before we lift off on the inside and the outside of the box. And then we will monitor the distance it reaches, and we will record the data at every layer. As we reach the stratosphere, we will take 2 readings of temperature because of the 2 different layers they have in there.
Just like some experiments, that scan test there are some flaws with ours as well. There is an exterior heat called urban heat islands, which could change the actual temperature of the atmosphere before we lift off. Also, the sunlight going through the layers also could throw off the outside temperature of the box. Also, as we look, there will be some good benefits to our research that we can gather. Some of the benefits can be for radio stations and news channels. The information that we can collect can help them determine the temperature for a few days and how the temperature can cause weather to change differently and the pattern that is seen with weather change. If altitude increases, then the temperature will decrease, except when we enter the stratosphere. Our hypothesis should work for many weather reporters on news channels and on the radio. Also, finding the temperature will help figure out a pattern of how this affects the weather.